high school calculus, infinite series, Taylor and MacLaurine. So here's a claim that any function fx can be expanded into infinite series. So if you have a fx and around a, you can expand this fx into an infinite series. Okay, so the claim is assume this is equal. So determine this coefficient C0, C1, C2, C3. To determine the coefficient, you have to take derivatives again, again, and again. Then you can determine coefficient by this equation. So, is that correct? Now you have to know, we assume if fx can be expanded to a and infinite series, then coefficient like that, okay, ci equals, and the derivatives like that. But this assumption, if this is not true, then what happened? This is not true, right? So you cannot claim this is correct. So we have to be very careful. There are a lot of loaded condition in this Taylor series. Suppose we take epsilon as fx minus n I equals 0, right? And ci x minus I. If we take a difference, we take not the infinite series, only n series, and the difference we define this by this, okay? So there is a condition that if xx is a certain value at a, okay, then by taking a limit, we can prove this is 0. So this is going to be complete mathematics proof. Okay, so we have to pick such a function that we can expand into infinite series and pick that value a properly. For example, if fx equals 1 over x, okay, and you take a equals 0, what's happened? X is here around a, and when x is very small, this gonna diverge. So you cannot get this condition, okay? So this is a condition to be able to use this infinite series, and the name of this infinite series called Taylor series. Okay, so why do we do that? Because sometimes the function is expanded to infinite series, we can do something we couldn't do with original fx. And that's the kind of things we learn in the calculus here. Okay. Now, for example, ln x log x, right? So if you expand fx equals log x equals ln a plus x minus a minus x minus a square 2a square plus 3a square x minus a cube minus so and so. If a is not 0, we can prove the difference between this and this is going to be 0. Then this is a correct expansion. When a is 1, this is 0. The a is 1 everywhere. So Lx will be 0 plus 1 x minus 1 minus x minus 1 square plus x minus 1 cube minus so and so. Okay, they find the MacLaurin. Okay, we talk about MacLaurin now. MacLaurin is shown in the next one. So what is MacLaurin? MacLaurin is when a is 0 in Taylor series. That's MacLaurin. So equation becomes simpler. You look at this, it's just polynomial, infinite polynomial. So any function can be expanded into infinite polynomial. And later you learn the Fourier transformation. That's replace x by sine nx, sine function. Okay, so if you calculate it, a is 0, so f 0 over n, like that. So MacLaurin simplify by putting a equals 0. So since n's derivative of ex is always ex, expand ex. So fx can be ex1 plus x, you know, e0 is 1, right? So simple. Plus x square 2 plus x third 3 plus so and so. Okay, now you learned EIX and EIX, right? Euler's equation in trigonometry. Euler's formula. You put I, then it's become the sign alternate because of the I square. Okay, so the sign MacLaurin sin x will be x minus x squared 3 plus no, cube fifths, so on so, and the cosine x equals x 1 plus 1 minus x squared 2 plus x4 4 plus so on so. You put this together. Oh yeah, here. If you put together, it's become EIX, same as this one, I sine x. So Euler's equation is obtained this one. From this one, you can obtain cosine x equals EIX plus minus IX over 2, and sine x equals EIX minus EIX over 2i. Okay, so using infinite series, MacLaurin series, you prove this Euler's equation, which you use to prove many trigonometric formula. Okay, so I hope you feel very easy on this Euler's formula now, because you see the proof right here using infinite series. Let's look at the sum of infinite series. The sine, cosine, tangent, EX, and log minus 1, so on so. These are very important, but the condition is the range of x is limited. Here's a range. Within this range, it's possible. Okay? So that's about the infinite series in the high school calculus. I don't think they go beyond this example, and there are a lot of more things you can explore in the infinite series, but I think high school calculus, I think we just need to know what the Taylor series is and MacLaurin series is, and some function can be expanded into infinite series. Okay, I hope you enjoyed this video, and I'll see you in the next video.